probability. Here we go. Let's do this. The long promised video that I told Abby I would make and I was working on, and then life, children. But here we go. So there was something I left out when I was talking about this because I was confused on my end. I thought these were combinations, not permutations, but they are permutations, which means nothing to you. But whatever. Essentially what it means is that order matters when I'm picking these things. So that if I was picking 3 white cars, there is a different selection if I were to pick blue, green, red, white versus blue, green, white, red. The order of the white matters. Okay, and so, which is stupid and it's a small thing, but let me show you how to fix it. It's pretty easy. It's clue. This is the Pascal's triangle. Okay, so let's work on this. So we have a 1 in 6 chance of picking a white car. If I have a 1 in 6 chance of picking a white car, that means I have a 5 in 6 chance of picking a not white car. I don't care what color this is. All I care is that it's not white. This is the way probabilities generally work. I have a 100% chance of picking something. So if you know one of them is 1/6, the other piece is whatever's left, right? 20% chance of rain, that means there's an 80% chance that it's not going to rain. Math-wise, what you're doing is you're taking whatever probability you're given and subtracting it from 1, and that gives you what's called the complement, which is the leftover. Okay, so here we go. Here are all the options of possible things that could happen, and this should look really familiar. So this is the probability form of the binomial theorem. So I could get 4 white cars, right? So that would be 1/6 times 1/6 times 1/6 times 1/6, right? I have this 1 in 6 chance of picking a white car, 1 in 6 chance of getting a second one, 1 in 6 chance of getting a third, 1 in 6 chance of getting a fourth. I could write this as 1/6 to the 4th power, right? Well, let's say maybe I want to, what's my chance of getting 3 white cars? Well, that'd be 1/6 times 1/6 times 1/6 times 5/6. So if I want to write this like this, I could write it like this, 1/6 to the 3rd times 1/6 to the 1, right? And we could keep going. We could say, well, what about if I were to get 2 of them? 2 not white cars. Okay, well, that'd be 1/6, 1/6, 5/6, 5/6. And hopefully at this point, so this would be 1/6 squared and 5/6 squared. Hopefully you're starting to see the pattern. Look, this one's going down, this one's going up, and we would continue that pattern. Okay, I'm going to go down here so we have more room. So we have 1/6 goes down from 2 to 1, 5/6 to the 3rd, and then my last one is going to be 5/6 to the 4th. So the nice thing about this is that the number in black is how many of the white cars I'm picking. 4 white cars, 3 white cars, 2 white cars, 1 white car, no white cars. Number in red is the number of not white cars. 4 not white, 3 not white, 2 not white, 1 not white. Okay? So then if they say, well, what is the chance of picking 2 white cars? Boom. It's that probability right there. But here's the part I messed up. I thought these were called combinations, which means order doesn't matter. But they're not. They're permutations, which means that there is a difference between white, black, white, black, white, white, black, black, etc. Okay, so to account for that, that's what, if you look in your textbook, they have this, it looks like this. It's like 2 choose 4. Okay, that means I'm picking 2 out of 4. Really, it's the Pascal's triangle again. So I'm going to write it out. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Oops, there shouldn't be 1 over there. There are 4 things. So that means I'm going to go to 0, 1, 2, 3, 4. 4th row. So I just add those numbers right in the front. 1, 4, 6, 4, 1. I add all that up, it'll equal 100%. It will equal, yeah, whatever over, I think it's like 1296 over 1296. Okay, but this is the key. Once you've done this, the rest of the problems are pretty easy. So let's take a look at those other problems. I'm going to go back to them. Okay, what is the probability that all 3 cars sold were white? All right, let's go back. All 3 cards sold were white, boom, right there. That's our probability. And so I can write this a little easier like this. So we know that it is 4, 1 over 6. Oh wait, I think I have it backwards. 3 are white. I have it. So we want this one, not that one. 3. Okay. So we have 3 up there, and then we have 5 over 6. Okay. 1 to the third is just 1. Right? Here, let's do it this way. 4, 1 over 6, 1 over 6, 1 over 6, 5 over 6. And you want to turn this blue, so it all looks nice and pretty. 4. So I've got 4 times 1 is 4, times 1 is 4, times 1 is 4, times 5 is 20. So we have 20. Over 6 times 6 times 6 times 6, 6 to the 4th power. That is my answer. That's it. That's all I have to do. Okay, once you have that all set up, you plug it in. So pause. When I taught this in class, I forgot about this 4, right? 1 over 6, 5 over 6, that works. Like, I will totally take 1 over 6, 5 over 6. You're doing it basically the right way. You're making a little mistake that I made, so I don't care about that. But in order for it to work out perfectly, you need that number. So let's go back over here. Let's look at the next problem, which is the at least thing, which is the one that you guys all are watching this for, hopefully. What is the probability that at least 2 of the cars sold were white? Okay, so if I want at least 2 of them are white, if I have all this, it's easy. Well, that's 4 cars, that's 3 white cars, that's 2 white cars. Do I have a highlighter? Can I use a highlighter with this? Let's see. Yeah. So essentially it is all of that. These 3, I add those 3 numbers up, that gives me the probability that at least 3 of them are white. Okay? The shortcut way of doing it, also, you can use the whole complement rule. I could say, well, I don't want to figure all this out. Well, then I just need to figure out what the chances are of having no white cars or 1 white car. Because that's the opposite of at least 2. So sometimes it's easier to do this than that. Like, for example, say I was picking, I have a 1/3 chance of picking 8 cars. What's the probability that I get at least 7 red cars? Some crazy math number. But I could figure out the probability that I get 8 red cars. Or no, I have it backwards. What is the probability that I get at least 1 red car? There we go. At least 1 red car. So that would be all red cars, 3 red cars, 2 red cars, all the way down to 1. But I could just figure out what the probability of getting no red cars is and subtract it. So you kind of go backwards. And sometimes the backwards method is way faster. Both work. But there you go. This is probability. This is the correct way to do it. Again, set up your equation with binomial theorem. That's the easiest way to do it because you have to have this Pascal's triangle. So again, 1/6 to the 4th, 1/6 to the 3rd, 1/6. That should be 5/6. Let's fix that because I'm going to share this work that I just did with this video. Okay, and so I want to make sure it all matches up. 5/6. There you go. And you can apply this same rule to, I think there's another one that's an at least. Here we go. What is the probability she will win at least 1 prize? So you know what? I'm going to do this one real quick, right? 1 in 10 chance of winning a prize. This is when you want to use the complements. If Chip buys 10 tickets, what is the probability that he will win at least 1 prize? So instead of figuring out, let's go to another page. Instead of figuring out the probability of getting 1 prize, 2 prize, 3 prize, 4 prize, 5 prize, 6 prize, 7 prize, 8 prize, 9 prize, 10 prize. That's a lot. It's a lot of math. I don't want to do. I'm just going to figure out, well, what's the chance of him getting 0 prizes? Because if I have the chance of him getting 0 prizes, the opposite of him getting 0 prizes would him getting at least 1. So let's do that. So we'll figure out what's the probability of him getting no prizes. So let's go back over here. He has a 1 in 10 chance of winning a prize. Cool. So he has a 1 in 10 chance. We'll do that in red. I know we'll do it in black. So he has a 1 in 10 chance of winning. That means he has a 9 in 10 chance of losing. I always mess up the word lose. I think it's 1-0. Losing. Right? So we want to figure out what's the chance of every single one of his 10 pulls him losing. Well, that's 9 over 10 to the 10. Okay? The other part is there's that blue number in front, right? We have to do that. So real quick, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4. So I'd have to go all the way down to 10, right, to get the right number. Wait. Do this last one. It should be 10 also. 5, 1. It's the last number. The 2 outside numbers are always 1. So that means it's a 1 here. So my answer is 9 over 10 to the 10th. Whoa! I messed up again. I'm double talking. 9 over 10 to the 10th is the chance of getting 0. So I'm going to say 1 minus 9 over 10 to the 10th. That is my probability of getting at least 1. Box and flower. Ooh, that's a good flower. That one's wrong. That's not the answer. There you go. Done. Finito. 12 minutes, answer the 2 problems. Hopefully that makes sense. Yeah, gonna make some more videos about what you're doing this week. So, yay. Adios, guys.